Hey good folks, I'm here for Tats Plus, and welcome to my Champagne Bottle Pop tutorial. New Year's Eve is just around the corner, at least it should be by the time I finish this tutorial. Plenty of champagne bottles would get popped during this lovely holiday, and I'm guessing that many of us would like to add a nice champagne bottle pop to their animations. And in this tutorial, I'll show you how to create that animation in Realflow and Maya. First things first, let's start off with Maya. Over here, as you can see, I've already created a bottle in Cork. I created the bottle using a CV Curve tool. You go to Create, CV Curve tool, and you just draw the outline of the bottle. And of course, I'm not doing a really good job here, but this is only for the general reference of how I created it. Once you have your bottle profile all set up, you need to make sure that the pivot is on the edge of the CV Curve tool. So let's hit Insert, click hold C to snap the pivot to the curve, and just middle mouse, click hold and drag it on this curve until you reach the end. Hit Insert again, and now we can go to Surfaces, Revolve, and there's our lovely bottle, which looks more like a vase, but yeah, you get the idea. This is actually very basic stuff. So let's get rid of these. Before we export both these meshes into Realflow, I would like to add a small animation for the bottle. Now, I would just like to point out that you don't have to create the animation in Maya. You can also create it in Realflow and then import that animation back into Maya, which would be the case for the Cork, but in this case, we'll just create the animation here in Maya. So, I would like the bottle to begin its animation in an angle of 35 degrees on the Z axis. Now, as you can see, let's set it back to 0. The bottle is a bit up in the air and its pivot is straight in the middle of the grid. So the rotation I get is slightly wider. Okay, now same goes for the cork. Its pivot is in the same location as the bottle's pivot. So we'll set both the cork and the bottle to an angle of 35 degrees on the Z axis. I'll choose only the bottle now. I'll go to frame 80 and just on the rotate Z axis, I'll right click and select key selected, which would create a keyframe. And I'll move over to frame 190 and set it to 0. And again, I'm not worried about the cork since I'll get its animation from Realflow. Back to our bottle. Would like to adjust the keyframes here a bit. So for that, I'll switch over to the graph editor. We'll go to Window, Animation Editors, Graph Editor. And at the moment the animation is very linear, I'll mark both keyframes and make them spline tangents and give it more of a ease in and ease out animation. So ease in and ease out. So this is a bit nicer. Next, I would like to export these two meshes into Realflow. However, in order to export any sort of mesh into Realflow, I'll need to have it triangulated. Since I already know that I would need to texture this bottle, and for some reason, and it's really just me, I like to UV map objects when they're quads and not triangles. So I'll duplicate just the bottle. Let's hide the first one. I'll rename the first bottle to bottle quad. And the second bottle, the duplicate, I'll name it bottle trig. Go to bottle quad and I'll need to copy its animation. I'll double click on the timeline to mark all of the timeline. Right click, copy, and go to bottle trig and paste. So I've got the same animation here. And now I can triangulate the second bottle, shift right click and choose triangulate. And there you go, we've got a triangulated bottle. The triangles seem a bit curvy, and that's because I've pressed 3 on the keyboard for the smooth view of the mesh. If I'll press 1, you can see it's straight. So back to 3. So Cork as well, shift right click, triangulate, and we are good to go. We can now export our meshes, but before I do that, I would like actually to jump over to Realflow, and here I'll create a new project. Go to File, New Project, and we'll call it Realflow Tutorial, and we'll hit Create a New Project. Close this one. The reason I did this is because now we have new and clean folders into which we would export the files. Back to Maya, we'll mark the bottle and we'll go to the Realflow tab. We'll mark the second button, the SD with options. Let's see. I'll choose Realflow Tutorial and Objects. Open, and we'll rename this one to Bottle Full, and you'll see why I'm naming it Full in a moment. We do have an animation here, so we want to export more than just one frame. We can mark the frames we want to export, or we can just mark the use playback range, which would use the entire playback range, which is 200 frames. We want to export selected, and we'll hit export. There it is. Now let's mark the Cork, and again, SD options. We'll call this one just Cork, and we don't need to use a playback here. We'll just use one frame, and we'll hit export. Now let's jump into Realflow. Here we are in Realflow. Let's go to Import, Objects. We are directly in our Objects folder. We'll choose Bottle Full and hit Open. We've got a camera here which we really don't need, and if we'll mark the bottle, let's see, we have got animation here. Very nice. Okay, let's hit Import, Objects, and we'll choose Cork, and we get a message here. Let's hit yes. The Cork would replace the bottle, so let's delete those, and again we'll import just the bottle, delete the camera. Let's move back to Maya for a second. This time we'll export the Cork. From File, we'll go to Export Selection, and we'll choose OBJ Export. We'll select Export Selection, and we'll export to the Realflow Objects folder, and we'll call it Cork, and we'll hit Export Selection. Now, if you don't have the OBJ export option available, you need to go to Window, Settings and Preferences, Plugin Manager. There it is, OBJ export. Let's go back to Realflow, and we'll again go to Import, Objects, and Cork OBJ. It's a bit turned around, so let's see. We'll need to rotate it maybe on the y-axis. Not 90 degrees, but minus 90 degrees. Okay, so there it is. Let's change the color of the bottle to gray. And we are good to go. We've got two methods to do this. The first one will be to fill the bottle with particles and create an internal pressure which would push out the cork and cause some of the fluid to burst out. And this method is very close to real life. The second method will be to fake it. We can create an emitter, place it close to the edge of the bottle, and with animating the parameters, we can get a very satisfying result. Now, the main difference that I find between these two methods is the simulation time. The first method, the internal pressure one, takes a lot of simulation time. And the second method, that is not as accurate, but we can tweak it so it would be as accurate as the first one, takes less time. So I'll show you both methods. In both methods, we need to make some adjustments for the bottle and the cork. In order for the water to push out the cork, we need the cork to be an active rigid body. So under dynamics, we'll set it from no to active rigid body. If we'll add gravity right now to the scene and start simulating, the cork would fall straight down because nothing holds it in its place. So we need to set the bottle to a passive rigid body. Again, under dynamics, we'll set the dynamics from no to passive rigid body. So first method, we'll fill the bottle with particles and create an internal pressure. Let's switch to wireframe mode by hitting 8 so we can see what's going on. Now, let's go to the emitters menu, these 3 dots here, and we'll create a fill object. Under the fill object tab, we'll set object to the bottle and hit OK. We'll set fill volume from no to yes. And now the bottle is filled with particles. But as you can see, something has went wrong here. The bottle itself doesn't seem to be filled with particles. What actually happens here is that the gap that we've got between the 2 walls, or the thickness of the bottle, is getting filled with particles. If we'll simulate, I'm not even creating any internal pressure here. I'll just simulate. All the particles will just fall down within the thickness of the bottle, which is really not the result we're after. So let's stop the simulation here, reset it, and let's go back to Maya. So what we need to do is get rid of the outside part of the bottle and just use the inside part of it. Let's go to the end of our animation and duplicate it. And I'll hide the original one. To get rid of this outside shell, we'll first convert the bottle back to quads. So shift right click and we'll go to quadrangulate. And there you go. Now let's switch to curves mode by hitting F10, and we'll, for instance, click twice on this curve and delete it. And so on and so forth. We need to delete all these curves. Now be sure to delete only the outside horizontal curves and not the vertical ones. And once you're finished, you can switch to face mode by hitting F11 and delete these faces. And you are left only with the inside shell. Now I have already created, let me just delete this one. I've already went ahead and created the inside shell bottle, and I call it bottle inside. And if I'll get closer here, you can see it's just the inside part of the bottle. And this bottle has no animation, so we'll need to go to the animated bottle and copy its animation. So double click on the timeline, right click, copy. We'll go to the bottle inside, right click, paste. And now it has its animation and we are good to go. So again, we'll export this bottle, this time under a different name. So we'll go to the SD export options and we'll export this SD sequence under the title bottle inside, and we'll use playback range and we'll hit export. Okay, now let's jump back to Realflow. Let's import bottle inside. We'll go to import object and there's bottle inside. We'll hit open and that would replace the existing bottle. We'll delete the camera. We'll convert it to passive rigid body. The cork is an active rigid body. Great. Now let's create again a fill object. Under fill object, we'll set the object to bottle inside and we'll set the fill volume to yes. And now we can see the bottle is filled with particles. Now we can safely start the simulation. We'll set the internal pressure to something around, we'll start with 10. Let's simulate and see how it goes. You can see some pressure is building up here. And the cork is moving just a tiny bit, but I really don't think that's enough. Let's reset here. We'll set the pressure to 100. That might be a bit too much, but let's see. So we immediately get a lot more pressure building up here. Well, I've let it render a bit and let's see how it goes. So it's getting pushed out very slowly, nothing too drastic. Right, so we'll need to reset that. We'll set the internal pressure to, let's say, 300. So we get a lot of pressure building up inside here. Create a gravity daemon. We would also need to create a kill daemon, a kill volume, and we'll need to scale it up. So when we got any stray particles floating around in space, they won't keep on floating on and on forever. They would die at some point. In that way, we won't get any crashes in Realflow. Okay, I think that's good. I'll run the simulation one more time and we'll see how it goes. Since I've added a gravity into the scene that caused the particles to be pulled down even though they have an internal pressure that causes them to burst up and push out the cork. For that reason, I had to raise the internal pressure amount to 3000. I simulated it for a bit, and as you can see, it did push out the cork, but at some point the particles get sprayed all over the place. As you can see, it works, but we do need to tweak it quite a bit. And this sort of simulation is quite time consuming, and since we don't have too much time on our hands, we want a quick simulation. So we'll jump over to the second method. Let's get rid of the fill object and we'll import the full bottle. And we'll hit open, and yes, we'll replace it. Let's reset the simulation here. Well, let's switch the color to gray. We don't need the camera. We do need the gravity and we do need the kill volume. Let's again set the bottle dynamics to passive rigid body. Let's create an emitter. We'll go to the emitter menu and we'll create a circle emitter. And we would need to place it in the correct position. So let's switch over to the side view. I'll try and place it in the correct position. We'll need to place it just beneath the cork. Okay, so this seems about right. Let's rotate it. 35 on the X, 180 on the Y, and minus 180 on the Z. Now, the size of the emitter right now is a bit too large, so we need to scale it down. Let's say 0.8. Now it's still in the thickness of the bottle, so let's say 0.7. That seems about right. So 0.7 all around. We need to place it straight in the middle here, so we won't get any stray particles in the thickness of the bottle. So let's simulate and see how it goes. Well, as you can see, we've got particles shooting out and bouncing off the cork. So obviously we need a lot more pressure here, right? So let's stop the simulation and reset it. This time around we'll go to the speed and we'll need to set up the speed to be a lot higher than it is at the moment. Let's try 10 for a second and see how that goes. So 10 does a pretty good job, right? We actually get a nice spray here, nice build up around the cork. All in all, you can see this simulation is going very fast when comparing to the previous method, and the spray itself is a bit too weak, but all in all I think we are in a good place. Let's stop the simulation, reset it. Let's set the speed of the circular emitter to 15. Now I don't want to shoot particles all throughout the scene. I want to shoot particles a certain time and then stop. After experimenting with this scene quite a bit, I have already got all the numbers I need. At frame 0, I wanted to shoot particles in a rapid speed, so I'll leave it at 15 and I'll right click on it and choose Add Key. And I wanted to shoot out particles for quite some time, and over time I would like the particle speed to slow down. So at frame 100, I'll set the speed to 5, and again right click, Add Key. And 60 frames later, in frame 160, I would like the particle speed to reach 0. Again right click, Add Key. Now let's double click on the speed here, and that would open up the curve editor. I'll mark the first frame and I'll make it a Bezier. Same goes for the second frame, and I'll leave the third frame as it is. Okay, let's close the curve editor. Now, as I said, I have experimented with this scene quite a bit, and I know that at this point the flow of the particles is very slow, and the particles would flow down on the bottle. And the way that the particles attributes are set at the moment, the particles flow on the bottle isn't too great. It actually tends to slide off the bottle quite fast. And I would like to slow that flow on the bottle. I can do that using the velocity or the surface tension or combination of the two, and that would work on the bottle, but that would also affect the behavior of the flow throughout the scene, which is not something I'm after. So for that, there's a special daemon called Magic. So let's go to the daemon menu, and there it is, Magic. What Magic does is it takes an object in a scene and it converts it into sort of a magnet for particles. So particles would get attracted to this object. So under the node Magic, we need to set object to bottle and hit OK. And here we've got two different parameters which we need to animate: the approach strength and the escape strength. The approach strength, the higher the amount, the faster the particles would tend to stick to the object, and the higher the amount of the escape strength, the less they are likely to escape it. We would first start in the amount of 0 for both the approach and escape strength. So at first, when the particles shoot out, the magic daemon won't have any effect whatsoever. And I would like it to continue on not having any effect up to frame 100. In frame 100, we'll right click and hit Add Key for both the approach strength and the escape strength. So Add Key. In frame 160, again I'm using the same numbers, we'll set the approach strength to 5 and the escape strength to 4. And we'll add key here and add key here. And we'll double click on the approach strength and make those two keyframes to Bezier. And same goes for the escape strength. Bezier. Wonderful. There are two more daemons I would like to add to this scene. The first one will be the kill isolated. This one will be in charge of any singular particles which might come apart from the main cluster. we would like to delete those so we won't have any stray particles. So we'll set the isolated time to 0.2. And one more daemon I would like to add to the scene needs a bit of explanation, and that is the shader. Let's mark all of these and we'll hide them and make them inactive. Let's create a new vase. Let's focus on that. Above it, let's create a new sphere. Let's scale this one up 2 by 2 by 2. Oh, that's too much. Let's say 1.5 to 1.5 on 1.5. Okay, so this is a bit better. Now this is only for the reference sake. I want to explain what the shader daemon does. Let's move this one aside a bit. I'll create a new emitter, a fill object. And I want to fill the sphere. So let's see. Object. We'll select the sphere, hit OK. Fill volume, yes. Okay, so now the sphere is filled with particles. We can make the sphere inactive and hide it. I would actually need a gravity in the scene, so I'll bring back the gravity. I'll make it visible again, though it doesn't really matter, and I'll make it active. Let's run this quick simulation here. You know what, that was actually a very poor simulation. Let's add some particles to the resolution. Let's make it 3. Okay, now let's simulate again. Okay. So, particles fall and spray out. Very nice, right? Now, let's reset that and let's add to the scene a shader daemon. And it's below the recording area, right at the bottom. We'll use the default settings as it is and see what it does to the particles. Let's simulate again. As you can see, this water spray looks a lot more realistic. And this is actually what the shader does. Let me stop the simulation. It looks for gaps in the particle cluster and it creates a sheet between those gaps. And it doesn't add any more particles to the scene. It just uses the particles already in the scene and spreads them differently. So that's what the shader does. We can now delete the fill object and the vase and the sphere. And we can bring back everything else. Let's make it active and bring those back. Reset the scene. So we've got a gravity. We've got a magic daemon. We have got a shader. I swear they really should have picked a better name for this daemon. We got a kill isolated and we got a kill volume. Now, the shader is a very good daemon and it does wonders to the simulation. But when the shader and the magic are working together, they actually work a bit too well together. Once the particle flow slows down and starts pouring on the bottle, the shader in combination with the magic causes the flow to really cover the whole bottle. For that reason, we would need to animate the shader as well. Here we've got in the shader the max cavity size. Default setting is 2, and that means that any gap that's larger than 2 won't be connected by the shader. So we will need to animate this value. At frame 140, we'll set a keyframe for the max cavity size to 2. We'll right click and add key, and at frame 190 we'll set the shader to 1. This way we can make sure that we don't have a perfect wrap and we would have holes in the liquid falling down or sliding down on the bottle. Now let's pay some attention to the cork. Let's close the node. On the rigid body, we've got the mass. Now, the default mass for the Cork is 1115 and some change. And that means that the Cork is very, very heavy. At first, when the particles are pushing out the Cork, I do want the Cork to put up a fight, because once it does pop out, it would fly away very far. However, since it is very heavy, it would pop out very fast and then lose its momentum and fall down. So we would need to animate the mass as well. We would need to make it lighter over time in order for it to fly away fast. To make it even easier for the Cork, I would like to create another gravity daemon for the Cork, which will be a lighter gravity, and that will help the Cork to fly away faster and further. So we'll start with the gravity daemon. We'll go to the daemon menu and we'll create another gravity. The strength is 9.8, which is the Earth gravity, but for the Cork we'll set it to 4. Now at the moment, both gravity daemons are applied to everything in the scene, and we'll need to take care of that in the exclusive links. But before we do that, let's animate the Cork. We'll set the object friction to 1 for the Cork as well as for the bottle. The higher the friction, the harder it would be for the Cork to pop out. So let's see. Mass. At frame 0, we'll add a key for the default mass. Right click, add key. At frame 3, we'll set the mass to 860. Right click, add key. And one frame later, at frame 4, we'll set it to 6. Right click, add key. Now, we've got everything ready in our scene, except that we've got 2 gravities, which affects everything. So what we need to do is create exclusive links. Let's expand these exclusive links here. Let's start with the bottle. I would like the bottle to affect the particles, as well as the Cork, gravity 1, and actually all daemons except gravity 2. Cork. I would like Cork to affect the circle, gravity 2, and the rest of the daemons, and the bottle as well. And finally, the circle emitter. I would like it to affect the bottle and the Cork, gravity 1, and the rest of the daemons. So basically, these 3 are very similar, except that the bottle and the circle obey gravity 1 and the Cork obeys gravity 2. And now we can delete all the global links. And it's safe to say that we are ready to render. I've stopped the simulation because I just remembered there's 2 parameters I forgot to add it here for the circle. I would like to add some randomization for the V and H. You can see here that the particle flow is a bit too ordered, so we'll set those two to 1. And I would like to set the resolution to 5, so I would get nicer meshing once we'll get to the meshing part. Let's reset this simulation, save and simulate again. Quick tip: if you would like the simulation to be a bit faster, you can hit Alt D to disable the view, and that would help the simulation to run a bit faster. Okay, so the simulation is finished, and as you can see, I've added a few more ingredients to the scene, and I've also adjusted a few settings here. So let's go over what's going on here. First of all, I've parented the circle emitter to the bottle to make sure that it moves with it as the bottle straightens out. And the way to do this is to go to the node section, and under parent 2, where before it was set to none, I've clicked it once and chose the bottle and hit OK. Other than that, since the emitter is pouring particles into the bottle itself, as well as shooting them outside, I've added another kill volume inside the bottle, and I've set it the inverse to yes, so that any particles that hit this kill volume daemon will be terminated, and that would save me quite a bit of calculation time. After simulating a few times, I found that the Cork is having a hard time to maintain its initial speed. That is to say, it loses its speed and falls down too quickly and gets caught in the particle flow. So, first I went to gravity 2, which is, to remind you, the gravity that's applied only to the Cork, and I've set its strength to 1. After that, I went to the Cork itself, and in the mesh animation, I got rid of the middle frame. I've set the last frame to be at frame 3, and its value is 6, and the first frame is set to 500. So now the Cork is very light and has no problem to shoot out very fast as it is in real life. And those are the only changes I made to the simulation, and after that I simulated this scene, which I have to say was very fast to simulate. After the simulation is done, I've set the circuit to be inactive and I've hid it, and I've added to the scene from the emitter menu n-binary loader. You can use binary loader or n-binary loader, they both work the same here. To this n-binary loader, under n-binary loader, I've loaded to it a bin sequence, the circle emitter's bin sequence, and working this way helps the meshing process to work a bit faster. After that, I've created a particle mesh by going to the mesh menu and choosing particle mesh render kit. Let's go over the settings here. I'm using spheres here, and usually I do prefer using metaballs. Metaballs tend to get a bit more blobby but more accurate, where spheres are smaller but less accurate. This time around I really prefer using spheres, and I've set the polygon size to 0.03, which makes it very accurate mesh, even though it might be a bit on the heavier side. And after that I went to filters and enabled the filter and set the steps to 250. Here is the result before your eyes, and I have to say I am very happy with this result. And of course, if I would add a floor here to the scene or some text for the fluid to fall on, it would be a lot nicer, but then again, in this tutorial I really wanted to focus just on the simulation and nothing more. Well, good folks, that brings to conclusion this tutorial. I hope you have enjoyed it and you find it useful. Once again, my name is Ram Ben Avraham, and I'll see you next time.